active log. So here's why we have logarithms. Here's why we have to have logarithms. What is 2 squared? 4. Good. 2 squared is 4. What's 2 cubed? 8. Okay. But what is 2 to what power is 6? I don't know. It's not going to be 2.5. But this is the reason why you have to have logarithms. Logarithms allow you to solve for exponents. When your unknown value is an exponent, you use logarithms to back itself out, to undo it. Because what happens here is that this 2 is going to be called a base. Okay? The value of 2 will be called a base, and obviously this x is going to be called an exponent. So logarithms deal with bases and exponents. Excuse me. So we wind up with what's called logarithmic form and exponential form. They are one and the same, but one has the word log in it. Let me show you. One of those forms is logarithmic. The other form is exponential. What's up, gentlemen? Got hands and things. Lou. Hey, Sarah. How you doing? Hey, do not open these. Shake it. That's I was going to buy one for myself, but I forgot. Here, shake this as you give it back to Hoffenworth, would you? Anyway, so one of these is logarithmic, the other one is exponential. Which one do you think is which?
Log.
Yes!
Wait, I have a question about the log.
Yeah.
Is the y plus x, is that like, where?
I'll explain it.
Okay.
Okay. This is logarithmic form. I don't think I spelled the word logarithmic correctly, but whatever.
Yeah, it's like log
Anyway, so if I worry about something called logarithmic form versus exponential form. What happens is that you can use, they mean the exact same way. It's just dependent upon how things are written. Now, when we go back to the idea a second ago, where I had the example of 2 cubed was 8, that's exponential form. What happens then is if I want to switch this into logarithmic form, it would be, well, if I look at 2 cubed equals 8, what's the base in that problem? 2. So it's log base 2 of 8 equals 3. That's what log form would look like. All right? So log form is the base of a log is the base of the exponential form. The base of the log is the base of the exponential form. And there's a formula for writing this out. It's log, and I just had this up here, log base b of y equals x. And it means the same thing as b to the x equals y.
Wait, so basically you just drop the base and then flip the other two?
Yes. How low can you go? Death row once again. I forgot all the words. I know that song too. What's that?
I forgot all the words, but you swear you know.
I know it. It's I haven't heard it. I gotta play it. Base, how low can you go? Death row once again. Incredible rhyme animal, the uncannibal deep, public enemy number 1, 5 votes set free, and I've got none. Can I ever tell them that I never really had a gun? What's the raps that Terminator X spun? Now they got me in the cell. His brother like me said, well, Farrakhan's probably you ought to listen to. But I say to you, what you ought to do is follow for now. Come on, it's Bring the Noise from Public Enemy from like 1986. I am something.
I wasn't alive.
I get it. You weren't alive then. All right, let me ask you this. What's 2 to the first power?
How do you do the base and then calculate?
Don't worry about it. What's 2 to the 0 power? 1. Now, this gives us properties of logarithms that we will utilize over and over again for graphing purposes. I think I kind of alluded to this the other day when we talked about when we graphed E. When we were graphing E values, all we had to figure out was the y-intercept and the asymptote. We would just move those around. When you get to logarithms, you're really only going to ever be 2 points to be able to graph, because everything else is just going to be real crummy numbers. So by using this kind of a property, you're going to be able to move stuff around. Because this basically says this. Log base B, excuse me, of B is 1. Think about what this would look like in terms of log form. Log base 2 of 2 is 1. Because 2 to the first power is how much?
Wait, 2.
This would be log base B. Let me just do this so I don't have to cough all over it.
Wait, so what is the log B of B of equals to 1?
Any base raised to a 1 exponent is always the base.
Oh.
Any base raised to a 0 exponent is always 1. That's what this means. Okay. So what happens then is that later on, if I wanted to figure out, what's that? 1. That's all I need. What this is going to allow you to do is pick values of x and y that work cleanly for graphing. And we'll talk about graphing tomorrow. I just wanted to show you the property today because it's a pretty easy property to work with. So mainly what I want to work on today though is being able to rewrite between logarithmic and exponential and see if you can solve a couple of these things in your head, because believe it or not, you can. Because once you get the idea of what does it mean to be going between logarithmic to exponential, as you read the questions, you're like, oh yeah, that's how that works. So, log base 2 of 32 equals 5, which means 2 to what power is 32? 2 to the 5th. That's all that means. That's what that means. Because remember, log base B of y is x. So b to the x is y. That's all we're worrying about for right now. How the logarithmic form switches back and forth towards exponential form. Here's log base 5 of 1 is 0, which means, how do you write that exponentially?
5.
5 to the 0 is 1. Okay. These work rather quickly, but what gets to, I'm going to skip C because it's pretty easy. I'm going to go down to the ones where you have decimals and negatives. Because what happens a lot of times within textbooks is that they write things in terms of decimals as opposed to writing them as fractions. What's 0.1? 1/10. So if you think about this, this is log base 10 of a 10th equals -1.
So you want us to convert it to a fraction?
Well, I want you to think about what does it mean. Because it's easier as fractional form because you learn via fractions that 10 to the -1 is not happy. So that means it's supposed to be 1 over 10. That's what you guys learned. That's what I taught you guys first semester. We talked about exponential rules. Excuse me. Same deal goes for when you have fractional bases, because that's perfectly fine. When you have fractional bases, you'll notice that log base 1/2 of 2 is a -1. See how it goes from a fraction for a base, and then you have a y value that's an integer, a whole number? That meant that the exponent has to be negative because you have to flip it. and it means the same thing going the other way. If you have a base value that's an integer, then all of a sudden you have a y value that's a fraction, that meant your exponent was negative. So this is nothing more than 1/2 to the negative 1. Just going back and forth between logarithmic form and exponential. Log base b of y is x. B to the x is y. Negative exponents flip fractions. Okay? That's all that goes for. So let's see if you can figure out one of these in your head. Log base 9 of something, good, is 1/2. Log base 9 of something is 1/2. Means 9 to the 1/2 power is x. What does half power mean again?
0.5.
No. Well, yeah, it means 0.5, but what does the 1/2 power mean when you're talking about an exponent?
It's a fraction.
You take half of this.
It's a square root. What's the square root of 9? X equals 3. Fraction exponents. We talked about these before, rational exponents. 1/2 power, x to the 1/2 equals the square root of x. Nth root. These properties don't change. They're still there. Okay? They're still there. Same goes for here. Log base 3 of 81 is what? Think. 3 to what power is 81? That's what it's asking for. 3 to what power is 81? That means 3 to what power is 81? So 3 to the 4th is 81. So x is 4. That's what you're trying to figure out. The values that we're going to utilize here are going to be such that it's not going to be scary because you don't need a calculator yet. Okay? Eventually you will use calculators, and I'll show you how you press the base buttons and stuff like that within the calculator, because it is really easy to do. This next one, notice, yeah.
So for the ones where they just kind of use the log, like a between the log 2 when you just sort of
Yeah, you're figuring out what is the exponent that the base was raised to get to that.
so just kind of whether like if you don't know you just kind of guess until you get it.
Yeah, because what's 3 squared? And 9 times 3 is 27 times 3 is 81. So then you could work through these.
Yeah.
They're not going to be, a lot of times when we do log-based stuff like this, it's not going to be anything like so grandiose that you can't figure it out. We try to make sure it stays within the realms that you've figured. Suggestion, decimals. Decimals suck. That's 4 1/100ths. What is that as a fraction? 1/25. Log base 5 of 1/25 is what? Well, 5 to what power gives you 1/25? It has to be a negative because it went from a regular base to a fraction, -2. So 5 to the -2 would be 1 over 5 squared, which is 1/25. And that's where that comes from. That's where that comes back from. Okay. Log base 1/2 of 8. Log base 1/2. Now if I switch that again, start thinking about exponent rules. 1/2 is my base. 1/2 raised to what power will give me 8, which means it has to be negative because you went from a fraction to an integer. So in the back of your mind, well, I don't care about the 1, but 2 to what power is 8? In order to flip it, you make it negative. So your value here is x equals -3. And we just did that 1 minute ago. Log base 9 of 3 means 9 to what power is 3? Half. And that goes back to the idea of using fractional exponents about how these things interact with one another or interrelate with one another. I don't think you're going to see fractional ones that are going to be any worse than a third, maybe even a fourth, because it might give you a fourth root of, like 81, or it might be 256, something along those lines that won't be horribly bad to work with, okay? So we should be okay. I think I already posted the problems.
Oh, I was gonna ask, do you want us to keep it in the fraction form, or do we have to put it back to the way it started?
You know, it's always easier to write things in terms of fractions than decimals.
So like the one with like the log 5, 1/25.
Yeah.
We don't have to put it back to like.
No. Because when you do stuff like that, you're going to see real quick that it's a lot. It's easier to do it in your head and work through it when it's a fraction, because then you remember your fraction was about flipping things.
So you don't have a preference?
No. Personally, I would keep everything in a fraction. I know the reason why they put decimals in there,
Yeah.
because it's quicker to put in a calculator,
Yeah.
but I don't want you guys to use a calculator.
Alright.
Okay? And we'll go from here. Try and knock some of this stuff out. See, I know I kind of breezed through that real fast, but in all honesty, those last 4 examples what we just did, that's kind of what these all are. Yeah. The first chunk of those just are just rewriting from log base to exponential. The last chunk is, can you figure it out? So it's good practice. We'll do it tomorrow in class. We'll knock it out and get it over. Because then tomorrow we're just going to be going over this and doing some graphing. Yeah, if you want to do that, that'll be fine. You want to pass out, you want to do that, and you can go from there, and then that way you won't miss the whole day. You missed a lot.
I can send you like a picture of it.
You let me know though, okay? Grab a flex test that way you can start if you have a question, or because you have to make up PE.
Yeah, you do. You make you walk last.
You walk around.
That is,
Bring a clipboard.
the world is just so stupid sometimes. But hey, whatever. But hey, don't listen, you got to watch the vlog video. But now, spend in the morning, you got to play. See you guys.